These are my personal solutions to week 5 of the course Introduction to Coding Theory. First question was answered in the live problem solving class. It was explained, so it is easy. C option, 1 goes with C, 2 goes with B, 2 has option B, 5 memory elements are needed, which are constraint length. 3 constraint length, question 3 has answer option C, which is 6 memory elements is same as constraint length as explained by Ashwant sir in live problem solving class. Question 4 goes with B, no, this is not catastrophic. Question 5 goes with B, so question 6 goes with A, question 7 goes with C, question 8 goes with A, question 9 goes with A, question 10 goes with B. Why does this happen? So this time I am trying to give reasons. First one, BCJR algorithm is designed to reduce BER, can be applied to linear block codes as well as convolution codes. Adrish sir in his lectures as well as TA teaching assistants have pointed this as answer, and it is straightforward. You just have to mark both. Then question 2 goes with 5 because in the lectures we have this controller canonical form can be drawn like this, and we will end up with 5 memory elements, or we can see in the generator matrix maximum power is 2, so 2 from here, and maximum power is 3 and 2 add up to 5. So this is short way of doing the solving the problem, and this is longer way of solving the problem. It points to answer option B, which is 5 memory elements, which is the constraint length of this controller canonical form encoder. Question 3 has 6 because each output V0, V1, V2, it will require 2 memory elements each in the observer canonical form encoding of this generator matrix. So you will have total 6, and if you want to draw, you can go ahead and draw. There will be 2 memory blocks for each. Question 4 goes with no because it is not catastrophic because there is a feedback. So possibly with feedback there will be no uncontrolled output, but still if you want to find it exactly, you have to find the GCD. That should be in the form d to power L. L will be any integer. So d to power L will not result because this and this will have no common factor. If you will try to find out, 1 is the common factor of these, and this 1 is not equal to d to power, so there is no memory element involved in GCD. GCD does not give the term d, and that is why it is not catastrophic. And this is my, in a sense, guess. So I tried my best, but I have found these reasons, could not go further into details, but most probably it is no. It is not a catastrophic encoder which will result in an infinite output sequence, infinite errors due to finite infinite input sequence will not result in finite. But again, when I say finite, it looks like it will produce finite sequence because this thing here will limit the output. Now I have to pump in an input which is a infinite, so if I multiply 1 by 1 plus d to both of them, then the output, if it is finite, then this will be a yes. So I am not sure. I think it now I feel that it is yes. But anyway, I will leave this to you to answer correctly, or in the comments please tell me what do you think. In question 5, you factor them out to find, after factorization it points to this option B. So minimal encoder is needed to be found. Minimal means you reduce it into a irreducible polynomial. So this is a irreducible polynomial and can't be further factorized, and then this matches up. So this is perfect, no problem, this is right. 5 goes with B. In question 6, systematic encoder, you just do the row operations and bring it into systematic form, so that message is here, parity somewhere here, and so basically this is identity matrix which will copy the message bits as it is in the second and the first bit output, which is this and this. And the third one is bit complex. What we had to do is we had to bring it into this form, I and P form. If this is done, then you can see that this is implemented easily. So possibly, most likely, yes, it is realizable. Then this is non-systematic feed forward encoder, minimum delay feed forward. For minimum delay feed forward, we just had this theory in live problem solving class, that if we multiply you should get something like this. So if we directly multiply this with GD, here it is done, GD is multiplied with the given option 1 1, you will get this, and which satisfies this. That means this is the matrix that will be a inverse, which will act as a inverse. So this is done. Then question 8, so 7 goes with option C, and question 8 is actually solved in the nodes. You see week 5 nodes, it is exactly in the solved in the nodes. So option A is for 8. Then these questions, last 2 questions, these are just need to see the theory, and with according to the theory you have to find the equation, plug in from one path you go, which is forward, which is the forward recursion alpha calculation. These are the 2 paths that reach in this state, 1 0 state. And how do we reach it? We reach it with alpha 0 0 or alpha 0 1, and we have both of them in gamma, and this aligns with option 1. Similarly for beta, which is so this is feed forward and this is feed backward or something like that. So how do you calculate it? Again, you need to see the final return, not incoming, outgoings, and you have these 2, this and this is here, and this is here, and you have these here and here. So it goes with option B. You just see the theory and populate the expression and you'll get the answer B as the matching answer. So 2 doubts remain. This one I think I will think over, and maybe catastrophicity might be yes, but at present I have marked it. Okay, I have marked it as no. So these are my answers. Please discuss if you want to discuss in comments, and if somebody can give a concrete answer to 4, that would be helpful. Thank you.